ladies and gentlemen. Now we come to the general conclusions and recommendations on the feeding studies and alternative approaches for assessing GMO health risks. These general conclusions and recommendations are an extract of what you can read in the booklet. So it's the general conclusions and recommendations of the whole GRACE team, not only of myself. And the first point I would like to make is we will have regarding design, performance, and interpretation of animal feeding trials with whole food feed for GMO risk assessment. We have placed a number of questions which we have answered based on the data we got within the GRACE consortium. The first point applies to a very important distinction between statistically significant differences and toxicologically relevant differences. When interpreting the results from animal feeding trials conducted in the course of the GRACE project, all statistically significant differences between groups have been evaluated regarding their toxicological relevance. That is, we not only look at asterisks. A single statistically significant difference is not necessarily indicative of organ or tissue-specific toxicity, which generally becomes evident in changes in several related parameters. Something that has been very controversially discussed in the stakeholder meetings is the value of historical control data when interpreting study results. Historical control data provide information on the typical variability regarding specific endpoints within a given setting and therefore help interpreting the study results and putting them into a context. The comparison of the test groups with the concurrent corresponding control group is always the most important consideration, but appropriate historical control data can help to interpret results in a number of perhaps controversial situations. If no such data exists in the testing facility, as was the case before the start of the studies A and B, additional control groups should be included in the study in order to allow for an assessment of variability of the individual endpoints or parameters that are measured. And ideally, historical control data should be generated by the test facility performing the trial within an appropriate period in time by using rats of the same age and strain and the same type of diet to estimate the lab typical variability of the measured endpoints. And these data, as I said before, are now available within the GRACE consortium. There's no doubt about that. Then we made a big effort in incorporating, as the European Food Safety Authority had recommended, the so-called standardized effect size approach. And based on the experiences gathered by the GRACE project, the SES, the SES approach eases the interpretation and contextualization of the gathered results by providing an overall picture of potential group differences and the associated magnitude of differences. And since this was a tiny bit controversially discussed in the last stakeholder meeting or controversially interpreted, the SES approach does not substitute for the toxicological assessment of the data. It graphically shows you in one picture where differences are, but in the end, we will have to do a toxicological assessment. Which are the triggers for the extension of the feeding trials within GRACE? The 90-day feeding trials A and B did not reveal any scientific trigger for an extension of the feeding period. Data gathered in the course of the one-year feeding trial, the so-called Study C, are in accordance with the conclusions made in the studies A and B. That means the feeding of maize MON 810 to rats did not lead to adverse effects. The one-year study conducted in GRACE did not provide relevant additional information when compared to the 90-day studies performed within the GRACE project. And then what is always asked is to include additional endpoints in the feeding trials. A targeted and testable hypothesis would be necessary to decide on the inclusion of additional endpoints in a feeding trial. Additional means in addition to that what is read in the OECD test guidelines and included in the EFSA recommendations and or statements. And when planning and interpreting the study, the biological variation of the tested parameter, we always come back to that point, so-called historical data of health, should be taken into account. And then the very often discussed, controversially discussed issue of a potential immunotoxicity. Immunotoxicity testing can provide extra information for safety assessment, especially in the case of new proteins to be incorporated into food and or feed, which currently do not form part of the human diet and may raise safety concerns based on initial in vitro and in silico analysis. Validated standard operating procedures for a number of in vitro immune function assays, this has to be honestly said, are still not available. And at the moment, different in vivo tests using animal models are available in the scientific literature. They have been discussed, but have not yet been validated for regulatory purposes. And something which we know of our own experiments, a high inter-individual variability in animal immune responses was observed and might limit the applicability of the assays. So, what are the general considerations of the animal feeding trials? GRACE did not provide any indication that the performance of 90-day feeding studies with whole food and feed would provide additional information on the safety of the maize MON 810 when compared to the compositional comparison of the GM line and its closest conventional comparator in terms of an initial safety assessment. The data generated by GRACE showed that non-targeted feeding studies may lead to outcomes at the level of the variability of the lab in which these feeding trials are being performed. That means randomly generating significant differences. GRACE data support the scientific reason that only in case a trigger is available from the initial molecular, compositional, phenotypic, and or agronomic analysis, feeding trials with whole food feed may provide an added scientific value for the risk assessment of GM crops. Thus, feeding trials might be considered provided that a targeted hypothesis can be developed to tailor the study designed to the post-safety concern. The need to provide nutritionally balanced diets determines the maximum inclusion rate of the plant material to be tested and thus restricts the exposure level of the animals to the respective food and feed. There is a natural barrier there that would lead, if you go up very high up with the inclusion rate of the plant material, to a so-called nutritional imbalance, and then you can forget the feeding trial. In the above-mentioned context, the expected magnitude of a distinctly identified potential effect should be included in the test hypothesis and trigger the decision whether feeding trial should, perhaps could be performed to achieve a clear test response. And in the very end, I would like to come to the triage aspect, which refers to the replacement, reduction, and refinement of animal feeding experiments, or animal experiments in general. Due to the intrinsic limitations of a feeding trial with whole food and feed, a mandatory performance cannot be justified in the light of the 3R approach based on the available scientific data. Omics approaches on plant material may contribute to the development of a target hypothesis in the future in order to scientifically justify the performance of feeding trials with whole food feed and to target the study design to the post-safety concern. The expected magnitude, again, of a distinctly identified potential effect should be included in the test hypothesis and guide the decision whether a feeding study could be performed to achieve a valuable information gain. And with this last slide, I thank you very much for your attention.